Auto refinement can automatically add a few design points to the model so that the corresponding response surface accuracy reaches the user's desired range. In fact, it's used to increase Auto refinement can automatically add a few design points to the model so that corresponding response surface accuracy reaches the user's desired range. In fact, it is used to increase the accuracy of contact surface using a repetitive process. This means that at each repetition stage, one or more design points are automatically added to estimate the contact surface. Therefore, the refinement option should be activated from the table of contact levels of output parameters based on tolerance, and then the tolerance value for each output parameter as a criterion or limit required to perform the process. This value of tolerance indicates the maximum value that the output parameter can accept. Thus, at each stage of the response level correction process, the maximum value of that parameter or output variable is calculated and its value is compared with the other maximum values obtained from the other stages of the correction. As a result, the maximum possible difference between these values is determined. It is also possible to manually define the refinement points in the table related to the refinement points. The refinement section has adjustment options. From the output variable combination sections, you can set the time to apply the new modifier points, so that the maximum output option means adding to correction point per repetition to amplify the minimum output, and all outputs mean adding a correction point has become non-convergent for each output. The crowding distance separation percentage option is used to define the minimum allowable distance between the correction points. The option of the number of refinement points indicates the number of design points created during the formation of the desired response surface. The maximum number of refinement points option is also used to define the maximum number of points that can be generated during the formation of the response level. This figure shows the settings section for correction points in the response levels section. This figure shows the repetitive process of creating design points. This iterative process continues until it reaches the desired tolerance. The horizontal axis, or x-axis, indicates the number of refinement points, and the y-axis indicates the ratio between the maximum predicted error and the tolerance of each output parameter. Convergence occurs when all output parameters are within the convergence threshold. Master CFD experts are ready for DOE analysis, consulting, training, and CFD simulation. To benefit from Master CFD services including simulation, consultation, and training, contact our experts via info@mastercfd.com.